Right, hello. Anybody who's here? Make sure this is- I'll give you a few minutes to tell me if you have any questions. Otherwise, we will do some maths. 8 to 12 in the year 10 maths booklet. On calculator foundation paper one. We'll see about the maths, given that we did the same thing last week. Um, okay, I'll just see if there's anything else first before I do that. So there was in the students that were in year 10 that did a lesson on quadratic equations. Um, So, just the last question that has just appeared about the homeostasis topic on the endocrine system. That coincidentally is exactly the topic that I will be doing with you on Sunday. Um, so, if it can wait till then we will do it on Sunday because that is the topic scheduled. The biology topic scheduled for this Sunday is the nervous system and endocrine system, all that stuff, basically. Yeah, nine, maths question seven. Fine. Yeah, as I said, when you specify the subject as well, because there'll be people that have done physics, because they'll still be behind. I'll do that. I'm trying to see if this is. I will begin in just a moment. Sorry, I was waiting for things to come through. Um, yeah, yeah, 10 maths booklet seems to be the one that's common. Hopefully that'll be useful. If you are in Key Stage 3, then I'll just do the one year 9 maths question that would come in first, and I'll just move on to that one. So in that one, question 7 looked like this. Hope you can appreciate my lighting setup. I made an effort to make this look a bit nicer. But anyway, year 9 maths question 7. The Work out the sizes of the angles marked with letters. So first thing I noticed is that this is a straight line. Therefore, the two angles next to each other on the straight line add up to 180, which means this angle must be 110 degrees. That would be that one done. I also notice that I have a triangle over here, which means that the three angles inside a triangle add up to 180 degrees. If that is 70 and that is 60, that makes 130. Add 50, that makes 180. This is another straight line. If that is 50, then this must be 130 because I have to add up to 180. At which point it starts to get a tiny bit more complicated because you have to use a rule about parallel lines. So if I tell you this situation, duh, duh. If I told you that those two lines up there are parallel, so we end up with like a bit of a C shape, then this angle here and this angle here add up to 180 degrees. It's like angles on a straight line, basically. They're called co-interior angles. Um, I just picture like this C shape, right? This C sort of thing, and the two angles inside it add up to 180. And we kind of have that same situation here. You see what I mean? It's on its side a little bit. Um, which means that the C and D must add up to 180, which means that C is also 50 degrees. And then B can be worked out because this is a four-sided shape, and the angles inside a four-sided shape should add up to 360. So you can do 360 minus the other three angles, which are 110 plus 360, 260 at 30 is 290, which means that that must be 70 degrees. And that is all of the angles marked with letters. And that is all I've got from that particular age group's question, unless something else pops up later on. I will move on to the year 10 maths booklet, which was on quadratic equations, which was quite difficult. I will accept this was a difficult homework booklet. So the ones that the students that I taught, I actually went through quite a lot of these questions in the lesson, as you may recall. Um, so starts from 8 to 12. You've asked for 10, 11, and 12. And so just 8 to 12, it feels like. And there's 11B as well. So 8 to 12 on this. And then I will do some of the other stuff that people have requested, like do a maths paper, whatever else you wish. So questions 8 to 12. Let's have a look at this, make it bigger. Um, what this is now, what you're looking for here is a particular topic called the difference of two squares, but I want to call it two square numbers because that's what it really is. The difference of two square numbers is when you have a um just one moment, sorry, I will go through this in just a second. Um just on your question about the substitute lesson for Sunday, there will be quite a few options starting from Saturday. So we'll figure it out. Um, factorize this difference of two square numbers. Now, if I said to you, like, let me just give you a strange scenario. If I said to you, 3 squared take away 2 squared, now that is 9 take away 4. The answer is 5. Now, what you can do with this, which you wouldn't do obviously if you had this question, you would just year 9 question 1b. I'll come to the year 9 book in a moment. This question that I'm doing right now is definitely in foundation level. Or I'll explain which one's foundation, which one's higher as we go through. Foundation level stuff is basically it's factorizing, but without more than, but it's always less than 1x squared, essentially. So this is included within that. So if I gave you this scenario, then you could, not that you would do this, is rewrite it like this. It would get you the same answer because it's 5 times 1. So when you have a situation where you have something squared minus another thing that could be something squared, in other words, 3 squared, then there is a way to turn it into two brackets. And that way is by doing x plus 3x minus 3. So you take these numbers and you just put plus or minus between them in two brackets. So if I gave you another example, if I said x squared minus 16, it would be x plus 4 times x minus 4, and you would have the same thing. So that is how you factorize those quadratic equations. And then in this question, I should be very clear that this would probably not, this would not be on a foundation level paper. Um, you would you'd have the top bit, but the whole question couldn't be because you wouldn't need to factorize these harder quadratics at the bottom. When a harder quadratic equation is when you have more than one x squared at the beginning. It's a little bit more complicated to turn it into two brackets. I will do it now, but it is way more complicated. So what you're supposed to do in this question is realize that the top bit is the same as the last question. So it is x plus 3 times x minus 3. That would be that. Then what we need to do with the bottom bit is we need to turn it into two brackets. Two brackets, like that. So for this one, okay, as I say, it is way more complicated to do this when there is more than one x squared at the beginning. If it's just x squared, and I don't know if we'll see a question on this anymore, but I'll do one quickly. If I gave you factorize the following, x squared plus 7x plus 12, then to turn this into two brackets is potentially much easier. What you're trying to do is find two numbers that multiply to give this 12 at the end, and two numbers that add to give the 7 in the middle. Those two numbers, hopefully you can identify, are 3 and 4, and they just go into the brackets with an x, and that's it. So that is a foundation level sort of question if it's just a single x squared at the beginning. When it comes to higher level stuff, you have more than one x squared potentially over here, which means that the process of doing this is a bit longer. So I'm going to do it, but I'll show you. This takes practice, I'll warn you, okay? To know how to factorize these things takes a little bit of practice. So what we shall do is you first still need to find two numbers that multiply to give something and add to give something, similar to the previous example. The add to give is the number in the middle, which is -5 in this case. The times to give isn't just the number at the end anymore. It's the number at the end multiplied by the number at the beginning, which is -6. Okay, so -6 add 1 is -5, and -6 times 1 is -6. And so previously, when you had the previous examples like this one here, that's pretty much all you did, and and you just put them into brackets and you were finished. There's more to do here when there's more than one x squared here. So now what I'm going to do, this is the bit where I might lose you, but you have to practice this. You split this -5x into the two numbers that you just found, which were -6 and +1. Okay, they were the two numbers that I just found, and I've rewritten that thing and split the -5 into -6, add 1. Once you split it, what you do is you pair up the first two and pair up the second two. And then what you do is you sort of look at them separately and you factorize each of them separately. So if I was factorizing 2x squared minus 6x, I would notice that 2 goes into both 2 and 6, so I'm going to take that out. And there's an x in both of them, so I can take out the x. That leaves me with x in the bracket here and -3 to get me back to -6x. Again, factorizing that stuff on its own is a foundation level topic, in case you were wondering. Just factorizing this kind of stuff. You should be able to take out common factors. Now, this bit's a bit weird because this doesn't actually factorize to anything because they are different, 1 and 3 and whatever. There's nothing there. But what you have to do in this case is you have to factorize it. And what you want is that you want to end up with the same bracket. And you should notice that if I want the same bracket here, that is the same as above, and I can just put a 1 outside it, because that is the same as what's above, because it is technically factorized. I've just put a 1 outside it. You wouldn't normally do that, but that is the same as x minus 3. And again, crucially, the way you know you've done this correctly is if you ended up with the same bracket twice when you do this thing. And I have, which means I know it's correct. So what I've got now is, remember, the whole purpose of doing this, I know I might have lost you, but the whole purpose of doing this is to end up with two brackets. Now, one of those two brackets is the bit that I've highlighted in yellow that I've got twice, which is x minus 3. The other bracket is this and this added together, so 2x add 1. So the 2x squared plus -5x minus 3 factorizes to this. There is occasionally a quicker way to do that, but I'm trying to show you the way that works every time. So that is that. Just so you know, the question, the year nine question 1B, I'll do after this question because that probably won't take me very long. 2x plus 1, x minus 3 is what this turns into as two brackets. Now, if you have done as many questions as I have, you will know that you could have guessed what was about to happen here. When you get this kind of question where you've got this weird algebraic fractions and stuff like that, and you have to simplify it, the way to do it is to get brackets on the top and brackets on the bottom, which is what I've done. And always what happens is that you end up cancelling one bracket because you end up with the same thing at the top at the bottom. So you have an x minus 3 there and an x minus 3 there that cancels out. So the answer to this question is what you're left with, which is x plus 3 over 2x plus 1. And as I say, once you do enough of these, which you will, you will get to the answers. Right. Let me just do this question that has been asked, year 9, question 1B. I'll just do that first because it's the only other one, and there's loads of the other ones to do. That's not it, is it? I'm in the wrong place. No, it is. Okay. There could be a mistake in this question. Um, right. You are this has ended up in this exam paper by accident, just so you know. This shouldn't be a question. But I will do it for you, but you will have absolutely no idea how to do it unless you have done trigonometry. Hopefully everybody else here will know how to do this question. But this has fallen into a Pythagoras booklet. This is not a Pythagoras question. Okay. I'll just tell you, so you can write it down. Okay, but there's absolutely no way you would be expected to know this. In this kind of topic called trigonometry, you label the sides. The side opposite the angle is called an opposite. The side opposite the right angle is called the hypotenuse. The one that's left is called the adjacent. You then identify which sides you care about. You're trying to find DF, so that's this one, and you know that one. So we're going to use from SOHCAHTOA, which won't mean anything to you if you've not done trigonometry. TOA, because it's got the O and the A in it. What does that tell you? It tells you that tan of the angle, which is 33, equals the opposite, which I'm going to call x for now, I'm trying to work out, over the adjacent, which is 12, which means that the x is 12 multiplied by tan 33. 12 times tan 33, calculate. 12 times tan 33 is something you do on the calculator, and it gives you 7.8. The answer to this question is 7.8. You could not do that based on what you would have learned in the lesson. It's just ended up in this paper by accident. That's all. That's why you couldn't do it. So don't worry about it. Let me move on back to here. Oh, not the wrong one. Okay. Question 9 said, use the quadratic formula. I just want to make sure that the quadratic formula, because sometimes I forget what is on sort of higher level and what's on foundation level. I do occasionally forget. So I'm just going to double check quickly. I'm fairly sure it's on both. Solving quadratics. No, it's not. Never mind. It's not. Okay, so this question is not on foundation level. So there is a formula that you get given. Somebody asked me a question. Um, in case I have to remind everybody, if you are an anonymous attendee into this meeting, I will not be answering any questions. And also, when you do ask a question, to specify which subject and which year and which booklet and so on. Use the quadratic formula to solve this. So the quadratic formula, you should have, depending on whether you got it in the notes, but if not, you can Google what it is, because you always get given it, so you don't need to learn it. But it is minus b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c represent numbers, and they represent the following. The A is the number in front of the x squared in a quadratic equation. The B is the number in front of the in front of the x in a quadratic equation. The C is the last number in a quadratic equation. Um, Year 9 and question 13. Okay, fine. I'll get back to that. I'll have to just alternate because I didn't see it earlier. Um, so in this way, this is really easy, right? Once you've done this bit, let me just quickly open up a calculator because otherwise all of this is a pain. Calculator. Okay. Um, all you do now is you sub those numbers into the question. So this shouldn't be that difficult as long as you know how to use a calculator, right? What you have to do is go, well, my A is 2, B is -5, C is -4, and you put them into this equation. You do it twice, once with a plus and once with a minus on your calculator. So really now, this is a test of whether or not you are able to use a calculator. Can you sub these numbers into a calculator? You have to be careful with negatives. So if it says minus b and b is already negative, that makes minus minus b. So it becomes a positive. Plus, but you know what? I'll press that button first. 5 plus the square root. Now, b is -5. It is being squared, so it's going to be 25. I'll just put that in. -4 times a, which is 2, times c, which is -4. So put all of that in like that. Over 2a, again, a is 2, so 2a is 2 times a, which is 4. So that's my first equation, having subbed it all in. And it should give me one of the answers, and it says it's 3.137. Two decimal places is 3.14. And then, because the equation says plus or minus, you have to repeat everything and do it with a minus. And this is why it's so helpful to know how to use a calculator, because now all I can do, rather than type all of that again, I can move that there, delete that, press minus. So I've just redone the question with a minus now, press equals, and I get minus 0.64. And we're all good. Okay. Right. I'll do that question. I'll mix and match here because it's boring otherwise. Question 13 on this one. If there's any trigonometry, I'll tell you you don't have to do it. And it is. Um, no, it's not. Never mind. Um, Question 13. Here is a triangle. Explain how you know from the information given that the triangle is isosceles. What does isosceles mean? An isosceles triangle is one where it has two angles that are the same. In this triangle, if I wanted to work out the third angle in this triangle, I can because I know what the other two angles are. So I know that's 90. So what I can do to work out what this missing angle is do 180, take away 45, take away 90, which incredibly equals 45. So what you do now is you explain that there are two equal angles in this triangle of 45 degrees, which makes it an isosceles triangle. That's how you know. Um, um, Show how two of these triangles can be used to make a quadrilateral. When you just join two together, when you just do like, oh, sorry, like that one, and then like, oh, so bad drawing, like that. I think that's it. If you join those two together, don't you make a four-sided shape? I think that's it. Um, Name this type of quadrilateral. It's gonna be a square, isn't it? Because you're gonna end up with 90-degree angles in all four corners. Okay. Show how they could be used to make a different quadrilateral. I think what you do here now is, I'm not sure. I'm not, you know what, I can look at the answers. Sorry, I've got them open, so let's look at them. Question 13 on that one. Oops, here. Sorry, give me a minute. think the answer's going to be rhombus, but I might be wrong. Oh no. Um, okay, so how they could be used to make a different quadrilateral. Triangle joined on shorter side with right angles not adjacent. Okay, I actually don't know how this works. Okay, yeah, if you join them like this, something like that, those two triangles. Oh no, that's completely wrong. Yeah, no, that's correct. Sorry, that is correct. You get. Nope, let me draw that again. If you join them like that, then believe it or not, that is a parallelogram. That's very hard to do that question. Anyway, that is the answer. Yeah, sorry, I'm just getting to that. I'm getting to the yeah, I'm back to the year nine things. Yeah, that's that done. Right, that's all that done, right? So year 10, sorry, year 10, year 10. Yeah, math year 10. Last part of question nine. Can you play the last part of question nine? I don't know what you mean by the last part. Want to be more specific? Um, uh, um, because the whole thing's one part. What did I do? I substituted the numbers in. I substituted A, B, and C, which are 2, -5, and -4, into this equation. Was the last part where I did it twice? So I did it once because the equation says do plus and minus. It means that I did it once with a plus, and then I did it all again with a minus. That literally is the only difference. That's why you get two answers. But tell me if that isn't clear. Um, Question number 10. Again, these are tough questions. I'm going to just be straight about it. This is a really hard question. But if I start it off for you, I'm hoping you'd be able to know what to do next. With this question, um, you would say that because let me just answer that last bit. Um, okay, maybe I just typed it in wrong. Okay, right. Let me just see if I did that right. Let me see if I've done this right. Um, so you're saying that you typed it into the equation but didn't get the same answer. Hmm. I think all the only thing I would say is without actually, you know, physically seeing what you're doing. The only thing to be careful of is when you're squaring a number. So if, for example, you over here, I'm not saying you did this, but you might have done. But if you have put -5 squared like that into your calculator, it will do it wrong because it will square the 5 first and then it will attach the minus to it. So if you're going to do this, you need to make sure that you put this in brackets. Again, I'm not sure that you did this, but I'm just saying if you have done that, then you that should be the answer that you get. But if you haven't put it in brackets, then it'll give you the wrong answer because it'll square the 5 first. It's a bit like if I said to you -5 squared. Now we know -5 squared is positive 25, but the calculator will tell you it's -25 because what it does is it applies the rules of BIDMAS where it squares the 5 and then it sort of multiplies it by the minus kind of thing. It does indices before multiplication. So if you are going to square a negative number on your calculator, that's why I didn't. I just put 25 in when I did it. But then make sure you put brackets around it. Again, hopefully that solves the problem. Right, this question. If you, how do I explain this? The first thing to do is recognize, okay. No, it's not because of the R and the D. That isn't the reason for that. I'm telling you, it's not. The reason the R is there on the calculator is a different. Is nothing. It's not to do with this. It doesn't affect this question. So that's not the reason. Okay. So I'll just. Sorry, I'll do it. I'll do it just one more time. Just explain. This is how I would put this into the calculator. I would have done if I do it all again from scratch. minus b. Just be careful. The b is a minus 5, so you need to have a positive 5 at the beginning. Or you could put minus minus 5 if you like. Um, do the fraction bit first. 5 plus the square root of b is minus 5, so minus 5 squared minus 4 times a, which is 2, times c, which is minus 4, over 2a, and that's 2 times 2, which is 4. So I get 3.14. I thought I'd get it wrong that time. 3.14. And then if I do the same thing and just change that first plus to a minus, because we have to do it twice, once with a plus, once with a minus, then I get minus 0.64. I can't, without seeing what you're doing on your calculator, I can't see what else is happening. Right, going back to this. Solve the simultaneous equations. When you have y equals something and y equals something else, then if you think of it logically, it means that this and this must be the same. It's like if I said to you that y equals um I can't explain this properly. Never mind. But if I said to you both of these things equal y, then they must equal each other, right? Otherwise, that doesn't make any sense. So this thing and this thing are exactly the same because they're both y. So I'm going to write that down. I'm going to say that 2x squared plus 7x minus 1 is equal to or exactly the same as 4x plus 1. And so this now becomes a quadratic equation similar to the ones that you have been seeing. The crucial difference is just remember, and again, depending on what you should have been covered in the lesson, but quadratic equations like this can only be solved if there is a zero on one side of the equation, if it equals zero. And at the moment, you have this stuff on this side. So what we want to do is move that away so that you get a 0. Um, if you take away the 4x, then you get 3x. If you take away the 1, you get minus 2. Now we can solve this quadratic equation. You can choose how you would like to do it. You could try to put it into two brackets. And remember that it's quite complicated to do that because there's more than 1x squared at the beginning. Or you could use that big quadratics formula again. At the moment, I would probably just say use that formula because you've kind of just done the previous question. You know how to do it. Remember, that is A, that is B, and that is C. So you would do this with minus B plus or minus the square root of B squared minus 4AC over 2A. So you'd sub all of those bits in, A, B, and C, and you would do it once with a plus and once with a minus. The question from the calculator paper 3, that was the OCR one I gave you, isn't it? I will do that once I've just got through these people's questions. Right, question 11 is called completing the square. Again, I'm hoping you did this in the lesson, but if not, I'll tell me and I'll do a little recap of it quickly now. Um, um, the quadratics formula will be in the formula sheet, which regardless of your exam board. Yes. Yeah, for all of you, believe it or not, again, by the time you get to your GCSEs, because you all will get this additional help that you perhaps didn't get before, but you will definitely get the quadratic formula. So this is called completing the square. How do I know that? It's because this particular format, this thing, when you look at it, which is a bracket with an X in it, something else in it, a squared outside and something outside. This format that you're looking at is something called completing the square. In order to complete the square, this is what you do. Right, just for future reference, right? If you have any questions about the Year 9 booklet, then let me know. I've already done quite a lot of the questions from it. If you are late in arriving, then you can obviously see it on YouTube, but I can possibly get to some of the questions. Right, to do this, what you want to do is put this x in there. Remember, when you're doing this thing, you want to put the x there, you want to put a squared there. That should never change. What you want to do next is halve this number. So if it's a minus 10, it halves to minus 5. So you've kind of done half of it already. That's how easy that bit is. The next bit requires a little bit of thought. What you have to do is when you expand this bracket out, I can just tell you what you're going to get is x squared minus 10x plus 25, because that 5 at the end will square to 25. Now, what you want, though, is for it to look like this. And as you can see, that doesn't look exactly the same as that because we've got a 29 at the end, but when we expand it, we're going to have a 25 at the end. How do you fix that? Well, how do you make 25 into 29? You add 4 to it. So this becomes what we call like an adjuster. You put that at the end here, which gets you back to that plus 29. So the way I do it is that I just say, okay, well, when I square this 5, what will it give me? It'll give me 25. But what do I want? I want 29. So I'll add 4. And that will get me to the answer to the question. Okay. Um, okay, I'm just going to tell you the answer to this question. The answer to this question is um, okay. So one of the benefits of completing the square is that you are able to look at it and see what's happened to the bottom of a quadratic graph. So because the bottom of this quadratic graph is at 3, 5, I know that it has gone 3 to the right and 5 up from where it began, and it always begins like that. So that's y equals x squared. Um, a little bit of an advanced topic. We will get that. And so, anyway, that is what I know that the equation of this is something like this, because I can tell by the 3 there and the 5 there, basically. And because they want the answer looking like this, what I now need to do is expand all of this back out again. If you expand the bracket, it will give you x squared minus 6x plus 9, and you'll add a 5 onto it, and therefore you'll have x squared minus 6x plus 14. And now it looks like the answer there, and you've done it. C and D. C is minus 6, D is 14. Was that it? Oh, there was someone. Let me just check what everybody asked for. Up to 12, I think everybody said. Right, I will stop at 12 and I'll go back to the other one, as well as what anybody else has asked. Yeah, right. Question 12. I thought I did question 12. Anyway, I'll do it relatively quickly. Um, the foundation bit, no, completing the square won't be in foundation. So the only bit that you need to be able to do for, in terms of this particular section of this booklet, was factorizing stuff like this. Make sure you can do that. I can tell you how to do that if you want. You would take out a 3, you would take out a y, leaving you with 3y minus 2 in brackets. That is, oh wait, I missed out. There's a squared here somewhere. What's a squared? Um, that's the kind of stuff you need to be able to do foundation level, and also the one that I mentioned about 1x squared at the beginning, when you're turning it into two brackets. Completing the square, this bit isn't in foundation either, fairly confident. And neither is this. Okay, so although actually, again, the first part of this, I see no reason why it couldn't be at the end of a foundation paper. So this definitely could be. I'd say part B less so, but part A definitely. Show the shaded area is given by this. Okay, when you see questions that say show that, then don't worry about the thing you're trying to show, which seems like the wrong thing to do, but it is the right thing to do. Um, and then just look at what it says here. It mentions the shaded area, and there is the shaded area. Now, how would you find this shaded area? Well, the only way to do this is to find the area of this entire big shape and then take away from that the area of this small shape. That will leave you with the bit around the outside. So I like to write down something like big area minus small area, just to make it really clear as to what I'm about to do. I'm about to find the area of the big rectangle here and then subtract the area of the little rectangle. If you write a little plan almost, I feel like you're less likely to go wrong or get mixed up or anything like that. Right, the big area is this number multiplied by this. That is how you work out the area of a rectangle. You times the length by the width. So I'm just going to write that down. 3x times 4x plus 1. Remember, when there's brackets and stuff, you have to keep it and then multiply them out carefully. minus, I'll come back to this in a minute, the small area is these two multiplied together. 2 times 6x minus 3. That is your small area. So I've got my sort of planned answer done. I just now want to expand it all out. 3x times 4x is 12x squared. 3x times 1 is plus 3x. And then all you have to be a bit careful of here is that this is now a minus 2. So it's actually minus 2 that's being times by the 6x, which gives you minus 12x. And it's minus 2 that's being times by minus 3. Minus times a minus gives you a plus 6. That little bit there, just be very careful of. Let's simplify. I've got in the middle 3x take away 12x, which is minus 9x. And then I've got a plus 6 there. And then once I've got as far as I possibly can, I have a look at the thing I crossed out. And it turns out, of course, that what I've ended up with is exactly the same thing I was trying to show, which is why it's unhelpful looking at the thing you're trying to show usually. It's just look at it near the end. And that's it. That's all you shouldn't need it at the beginning. Right. And then it says the shaded area is 6. So they're telling you this thing, which you worked out as being the shaded area, is 6. And then it says calculate the value of x. Okay, this is slightly easier to solve this because what happens here is that your 6's disappear. They cancel out. So you've just got 12x squared minus 9x. And you can just factorize this in the normal way with a single bracket again. That would be a foundation level question, factorizing this. Take out 3x, because 3 goes into 12 and into 9, so there's a 3 outside, and x goes into both x and x squared, so the x has come out. What's inside? I'm going to have a 4x here, aren't I, to get back to 12x squared, and then I'm going to have a minus 3. And all of this equals 0. When you have this situation, you usually just need to look at this bracket and say 4x minus 3 is 0. Add 3, divide by 4, x is 3/4 is the answer to this question. That last bit was just solving this equation, which you should be able to do. Okay, I think that covers all of those, right? I'll just cover off the latecomers in with regards to the Year 9 maths booklet, and then I'll do some of the other bits. Question 4, Year 9, question 4. This is applicable to everybody, by the way. Foundation, higher, all the other stuff. Oh, okay. Good question. I do say so. The rectangle and the right-angled triangle, have the same perimeter. Work out the value of x. Okay, what does perimeter mean? It means you add up around the outside. So if I know this is x, then this side must be x because it's a rectangle. And if I know this side is 1, then this side is 1 because it's a rectangle. The perimeter of this shape is x, add 1, which is 2. So in fact, what I'm going to do is the rectangle. This is what I mean by planning things out a little bit. The rectangle perimeter equals the triangle perimeter. It tells you this, doesn't it? In the top. The rectangle perimeter is x, add 1, add 1. That is 2x, add 2. Okay, now all we need is the triangle perimeter. I have a problem. I don't know the triangle's perimeter because I don't know how long this side is. And I can't like call it x or whatever because that's not the same as that necessarily. But the topic that you guys did, the topic that this clearly relates to is something called Pythagoras. And Pythagoras involves saying that in a right-angled triangle, the short side squared plus the other short side squared equals the longer side squared. Okay, that's how that formula works. It's called a squared plus b squared equals c squared. I just like to call it short squared. So let's just call this for now. Let's just call it y. I will be able to work it out. So the rule of Pythagoras tells me that y squared, that's this side squared, added to the other side squared equals the longest side squared. And so if I replace what I know, the 3 squared is 9, the 5 squared is 25. Y squared, therefore, if I take away 9 now, 25 take away 9 is 16, and y is the square root of 16, which is 4. So I have worked out that y is 4, which means the perimeter of this triangle is 4 plus 3 plus 5, which is 12. So by setting out my plan for my question here, I have got to a position which should be nice and easy to finish off. Take away 2, divide by 2. And x is 5. Can we also do question 5? Oh, sure. Cape Point is 7.5 kilometers east and 4.8 kilometers north of Arton. There's Arton, where that is. So there's your 4.8 kilometers north and then 7.5 kilometers east. Question is, surely to work out the distance. Yes, calculate the direct distance from Arton to Cape Point. This is just the same topic. It's another right angled triangle. You see this here? Right angled triangle? In which you are just working out the third side of the right angled triangle. And you follow the same rules, which is that the two short sides squared added together equal the other side squared. So 4.8 squared plus 7.5 squared equals, we'll call it x squared. If you work this out, you'll need a calculator to do this. 4.8 squared plus 7.5 squared equals 79.29. And then, so I'll write that down. 79.29 equals x squared. X is therefore the square root of 79.29, which is 8.9. And that's, what does it want? Yeah, that's it. That is the answer to the question. Um, it's just another right angle triangle. Hopefully that is sufficient for you to be able to deal with that. Right. Let me just go back through my questions again. 8 to 12, year 10 did all that. And then you mentioned a non-calculator foundation paper one. Okay, well, we'll be doing a foundation paper in a second. Done all that. Year 9, yep, done. Dealt with that. Okay, I think I've done all the questions that anybody had directly requested of me, apart from that. So there was another, and by the way, those of you who are mentioning foundation level, basically, oh no, my internet just went. I will be doing that stuff with you. Um, yeah, so I'll be doing that stuff with you in the some foundation level math, similar to the question I'm about to do actually. So what I need to do now is I need to find this paper that you have just referenced. Okay, so it was OCR, wasn't it? OCR Calculator Paper 3, November 2023. I think that's. Please tell me if I'm not getting to the right one. Um, Calculator Paper 3, November 2023. Calculator Paper 3. Okay. 11A and B. This looks like the question. I think you've asked me about. This one. This is from a foundation level maths paper. Um, and then after this, what I will do, just for anybody who wishes to stick around, is I will take a break for a few minutes, and then I will just do some more non-calculator, I think, maths. But obviously I can't do all of them. Um, sorry, the internet's been a bit dodgy today, so apologies. some connection issues. Um, right, this question. Uh, Gabby recalls the number of times a biased six-sided dice lands on each of its numbers. Complete the table to show the relative frequency. Now, with this question, if you don't know what relative frequency is, you do have a fairly large clue, which is how they have worked out these numbers here. Um, in fact, no, you don't. Never mind. Calculate the number of times a biased six-sided dice. Okay, it's not a great clue. What you have to do here is figure out how many times we um rolled this dice. And that is the sum of that row, isn't it? It's 5, 10 add 21, which is 31, add 7 is 38, 42, 45, 50. 50. We rolled this dice 50 times. Um, and what we then did was we said, okay, well, I got a three, sorry, I got five three times out of 50. Relative frequency is as a especially the fraction of times that I landed on that number out of the times I actually rolled it. So the way they've got to that 0.06, if they've done 3 divided by 50, that gave them 0.06. The way they got to that zero point 0.1 is by saying, well, we landed on a 6 5 times, so the relative frequency is 5 out of 50. It's just out, and that's 0.1. So out of the number of times I rolled it, how many times did I land on that number? So for the 4, I landed 4 times out of 50, which gives me 0.08. For the 3, I landed 7 times out of 50. So 7 out of 50 is 0.14. For the 2, I landed 21 times. 21 out of 50 is 0.42. And 10 out of 50 is 0.2. And then use Gabby's results to estimate the probability that the spinner lands on 5 or 6. Essentially, this becomes a probability, right? Because how do you actually figure out probability? It's based on what's already happened. Um, and so to work out the probability that it lands on a 5 or a 6, you add these two together. You say 0.06, add 0.1, which is 0.16. That is the probability that it will land on a 5 or a 6. Essentially, how do you do that kind of probability question? You add the probabilities together. Okay. Well, somebody asked me to do a non-calculator foundation paper 1. Okay, that therefore is edXL or AQA. I'm going to do this, but I'll do it in a few minutes, and then I'll do what I did last week, which was I raced through a foundation level paper. Again, applicable to anybody doing high level or anybody in year 9 that might still be around, because you still need to know all of that stuff. So what I'll do is I'll pick a paper at random. Let's do June 2019. Whatever that is. Okay, we will in just a moment go through this question. I'll give it a few minutes and I'll be back. Okay, quite fast. I want to get through all of this paper. Right, 180 minutes and hours. There are 60 minutes in 1 hour, so therefore the answer is three. Sorry, what am I talking about? I'm not reading it correctly. Right, 180 minutes an hour. Sorry, that is three. Sorry. 180 minutes an hour is 3 hours. Right, 0.73 is a percentage. That is 73%. You multiply by 100 to turn into a percentage. Um, okay, work out 10 times 3 plus 5. That is 10. Do you do what's in the brackets first, which is 8? 10 times 8 is 80. A prime number between 20 and 30. Prime numbers are numbers that are divisible by 1 and themselves. So you don't find them in any other times table. That's a better way to think of it, I think, apart from in the one times table and their own times table at the beginning. So those numbers will be, out of these, it'll be 23 and 29. I think they're the only prime numbers between 20 and 30, because 27 isn't one and 25 isn't one. Halfway between 7 and 15. If in doubt, if you need to find halfway between two numbers, add them together and half it. 11 should be between that. Harry is planning a holiday for 4 people for 7 days. Here are the costs for the holiday for each person. This is a non-calculator paper, isn't it? Yeah. Here are the costs for each person. Work out the total cost for 4 people. So for each person, we've got £150 of travel, £50 for each day in the hotel, and it's 7 days. So that's £350. 7 times 5 is 35, 350. And spending money, 250. So for each person, we've got £750 for each person. So, but there's 4 people. So what I need to do is times by 4. So you could times by 4 by doing the following, which you should definitely know how to do. Alternatively, to times by 4 is the same as doubling and doubling it again. Double 750 is 1,500. Double it again and you get 3,000. That's got to be the answer. Um, in Adam's garden, the flowers are only red or white or yellow or blue. Red or white or yellow or blue. The chart shows the number of red flowers, the number of white flowers, and the number of yellow flowers. So there are 8 red flowers, there are 10 white flowers, and there are 5 yellow flowers. I'll write that down up here. 8, 10, and 5. The total number of flowers is 30. Work out the total number of blue flowers. Well, we haven't recorded blue flowers on this diagram. So far, we've got 8, add 10, add 5, which is 23. And if there's 30 flowers altogether, then the 7 of them must be left, and 7 of them are blue. Write down the mode. The mode is the number that appears the most often. That must be, or at least the value that appears the most often. In this case, that is white, because there were 10 white flowers, and that is more than any other flower. Sorry, I'm writing very messily now. Right, the following fraction in order of size start with the smallest fraction. The easiest way to do this kind of question is to make sure your denominators are the same. That way it's easier to compare. Now I look at these denominators, 3, 4, 12, and 2, and realize that I can write them all as 12 because they are all factors of 12. I can change that into something over 12 by times top and bottom by 4. That's 4 and bottom by 3 to get 9 over 12. Again, top and bottom by 3 to get 3 over 12. That is already over 12. Top and bottom by 6, 6 over 12. And once you've done that, you just need to look at these numbers and see which one's the smallest, which one's the biggest, and put them in order. But that's what you want to do in an ordering fractions question. Get your denominators the same. Ruth left her home at 9 a.m. and walked to the library. She got to the library at 10:30 a.m. and walked at a speed of 4. Work out the distance. Distance is speed multiplied by time. That is your formula. The distance, the speed, it tells you was 4 miles per hour. And the time, now this is where you have to be a bit careful, is between 9 and 10:30. That is 1.5 hours, which is 1.5 hours, or you can write it as 1.5 as a mixed fraction. Now, 4 times 1.5, I mean, I know it's 6. The easiest way to times by 1.5 is to halve the number and then add it back on. So half of 4 is 2. Add it back on and you get 6. So 6 miles. Feels like a long way. Must be the answer. Ruth got to the library at 10:30 a.m. She stayed at the library for 50 minutes, which means it would now be. I do this when I'm reading questions because I know what they want you to do. So if it's 10:30, if I add 50 minutes to that, it's now going to be 11:20. Then she walked home. It took 1.25 hours to walk home. What time did she get home? 1.25 hours after 11:20 is 12:20 plus another 15 minutes. A quarter of an hour is 15 minutes. So 12:20 plus 15 is 12:35. I believe that is the best way to explain that. Solve this. When you get letters added together like this, you can simplify them to that. So t add t add t is 3t. 3t equals 12. Divide by 3, and you will get what t equals. Solve this. Just add the 2, and you get x equals 8. Solve this. Take away the 2 first. 20 take away 2 is 18. W is 18 divided by 6, which is 3. This is at this point, by the way, again, for those who are doing higher level, at this point you begin basically what the higher level paper will have. Work out 74 times 58. Well, uh, this is how I would do it. I appreciate not everybody does this in this way. Okay. I put a 0 at the beginning. I know most people put a 0 on the second line. I just do it at the beginning. And then I do 4 times 5 is 20. And 7 times 5 is 35. Add 2 is 37. And then I move on to there. 4 times 8 is 32. And 7 times 8 is 56. Add 3 is 59. You get these two rows. 0 add 2 is 2. 0 add 9 is 9. 7 add 5 is 12. 1 add 3 is 4. That should be 4292, unless I've done something wrong. Angles A, B, and BC are perpendicular lines. Perpendicular lines means that they meet at a right angle. So the 90-degree angle, which means all of this is a 90-degree angle. And since I've already got 25 and 25, which is 50, that means this must be 40. So that adds up to 90. More angles. Right. When I see this X, obviously this question just wants me to do stuff. So I'm just going to fill in as much as I can on this diagram. That's 125. So this is 125. Is that the answer to the first question? Write down the letter of one other angle of size 125B. Yeah, fine. Because there's a vertically opposite situation. When you see like an X in the reason would be vertically opposite. Explain is around a point all add up to 360. Okay. Now, if all of that circle effectively adds up to 360, and I've already got 125 of them, I would do 360 take away 125 to give me the rest of it. Okay. And that's where that number comes from, the 235. Length of a line is X centimeters. Write down an expression for the length of the line in millimeters. There are 10 millimeters in 1 centimeter, which means that if I had, for example, 3 centimeters, I would times that by 10, but I've got X centimeters. So in millimeters, it's just X times 10, which is 10X. Work out 1/5 of 70. To work out a fifth of a number, or a fraction of any number, actually, you take the number, divide it by the bottom number, and times the answer by the top number. 70 divided by 5 is so 5 goes into 7 once, remainder 2. 5 goes into 20 4 times. Fiona has to work out the exact value of 48 divided by a half. She writes 48 divided by half is 24. Explain what is wrong with Fiona's reason. Which is wrong. Dividing by a half is the same as timesing by 2. Okay, that's what it actually is. So that's just why it's wrong. Write down the value of the square root of 64. Write down the value of this. When you have a little number there, it means 5 times 5 times 5, which is 125. Expand this. 5 times 2m is 10m. 5 times minus 3 is minus 15. That's expanded. Factorize 3n plus 12. 3 is common, is a factor of 3 and 12, so that comes out, leaving you with n plus 4 in the brackets. Okay. Stuart throws a biased coin 10 times. He gets 7 tails. Maxine throws the same coin 50 times. She gets 30 tails. Prasha is going to throw the coin once. Whose results will give the better estimate for the probability that she will get tails, Stuart or Maxine's? The answer is Maxine's. The more times you do any experiment, the more reliable your results get. If you only do an experiment once and you just go, well, that's the result, that's definitely true, that won't be as reliable as if you did it 10 times or 20 times, because then you've got more results. You can see if something's gone wrong, just like you do in science, essentially. You repeat experiments to make your results more reliable. The fact that Maxine threw this 50 times compared to this person throwing 10 times makes the results more reliable or gives a better estimate. Okay. Use Stuart and Maxine's results to work out an estimate for the probability. Well, if you add everything up here, in total, it was thrown total 37. So if we just add everybody's results up to get a more reliable answer, then that would be the probability. Um, okay, we've got a rectangular garden path. We're going to cover the path with paving stones. Each paving stone is a square of side 30 a square of side 30 centimeters. Interesting. Um, we have £220 to spend. Each paving stone costs £2.50. Show that he has enough money. Right. The area that we need to cover. See, at this point, I'm wondering whether it's easier to do this in meters or centimeters. I don't know. Right. The area that we need to cover is 600 times 120, because that's an area, right? Area of that rectangle. 600 times 120 is, what's the quick way of doing this? The quick way of doing, remember, this is a non-calculator paper, so these are the things that hopefully will be beneficial to you. If I was doing 600 times 120 quickly, I would do 12 times 6, which I know is 72, and stick on the other three zeros. It's 72,000 centimeters squared. And then I've also got this little paving stone, which is 30, a square of side 30. So it's 30 by 30, which is 900 centimeters squared. Okay, then what I need to do is figure out how many of these stones I need to cover this area. So I need to know how many 900s go into 72,000. To do that, I'll do 72,000 divided by 900. Again, this is a non-calculator paper, but the numbers do make it a little bit easier than you may realize, because I can cross out that zero and that zero, cross out that zero and that zero, and then do 720 divided by 9. Well, 72 divided by 9 is 8, isn't it? Because 9 times 8 is 72. And then there's that zero that's still on the end. So the answer is 80. I need 80 of these paving stones to cover this space. Each paving stone costs £2.50, so I need to now multiply that by £2.50. How do I do that? If you want to multiply a number by like £2.50 and you're at the calculator, then your best bet is to go, well, let's do 80 times 2 and 80 times a half, because that's the £2.50. 80 times 2 is 160, 80 times a half is 40. That adds up to £200, and therefore he's got 220, so he's clearly got enough money. Times it 826. Work out 2/3 minus a fifth. This is the kind of stuff you need to make sure you remember for a non-calculator exam. You subtract fractions by making the denominators the same. In this case, 5 and 3, 15. Times this by 5, so you get 10 over 15. Times this by 3, so you get 3 over 15. 10 take away 3 is 7 over 15. To multiply fractions together, you just multiply, although you could try to simplify first if you wanted to. Um, I mean, in this case, I'm not really that bothered about it, but in fact, loads of this simplifies. The answer's a half. But 2 times 3 is 6, 3 times 4 is 12, 6 over 12 is simplifies to a half. So we've got there. At this point, this becomes suddenly quite a bit more difficult. Here are two squares, A and B. The length of the side of square A is 50% of the length of the side of square B. The length of the side of square A is half the length of the side of square B. So I'm going to pretend that this is 2x. they're telling you that A is half the length of B, so that we'll call X on this basis because we don't have any numbers here. Or we could use some numbers actually, but we'll just use this for now. Um, Express the area of the shaded region of square A as a percentage of the area of square B. Well, if I'm calling that 2x and 2x, then the area is 4x squared. If I'm calling this x and this x, then the area here is x squared if it was the whole shape, but clearly the shaded bit is half of that, right? So it's um 0 0.5 x squared. So half of x squared. Express the shaded, express the area of the shaded region of square A, which is 0 0.5 x squared, as a percentage of the area of square B. To turn something into a percentage, you divide the two areas together and times by 100. Now, when I do this, my x squareds will cancel. 0 0.5 divided by 4 is a little bit harder to do, but is 1 over 8. 1 over 8 times 100. This is horrible, this question. I'm sorry about this. 1/8 of 100 is, I think, 12.5%. That's a pretty horrible question. There are other ways to do that, but I've done it. Um, this is, I believe, usually the way you do this kind of question is something called a two-way table. Um, a two-way, how many questions are on this? That's 21. God. Um, so usually a two-way table works on this. So let me show you what I mean. This question is referring to students either walking, cycling, or getting the bus to school, and it references boys and girls. So this is what I mean by something called a two-way table. You make a little table where you've got sort of one variable on the top and one on the sides. Someone's asked me a question that I've missed. This is a non-calculator paper. It is indeed. Um, this is a paper one. So the other thing that you should do in these two-way table things is have a total at the end there and a total here. It makes your life much easier because it says there's 40 students in a class, which means that I want to put a 40 there because we're talking about 40 students all together here. Each student, yeah, there's 22 girls, so the total of the girls, oh, the total of the girls, which goes here, because that's the girl row, is 22, which means I already know that there's 18 boys, right? Assuming, you know, anyway, there's boys and girls, right? 22, 18, that is 40. Nine of the girls walk to school. So I'm going to put walking and girls as nine, because that's nine. Seven of the boys cycle to school. So there's seven boys that cycle to school. Six of the 10 students who get the bus. Now, there's quite a lot of information here. It's telling you there are 10 students who get the bus. So the total of the bus column is 10. Six of them are boys. I'm going to put a six there, which means four of them are girls, obviously. And actually, from here, you can pretty much complete the whole table because I've got seven and six here, which is 13, and the total of the boys is 18. So there must be five of them that walk to school. Five add nine is 14. So there's a total of 14 people who walk to school. Um, there are 22 girls altogether. We know about nine and four of them. That's 13. So another nine of them must cycle to school. Seven and nine is 16, and it all adds up suddenly. The question is find the number of the students who walk to school, which I figured out at this point when I got that 14 there. There are only blue. I don't even know if I've answered the question. Yeah, there are only blue cubes, red cubes, and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. The number of red cubes is the same as the number of yellow cubes. Is the pro if I've got the same number of red and yellow, then the probabilities of those two things must also be the same. The other bit of knowledge that is necessary here is that probabilities add up to 1, um, which means that these three numbers have to add up to 1. And I know that these two must be the same. So what's left here from the 0.2 is 0.8. And if those two have to be the same, they must be 0.4 each. Um, Okay, done that. And then there are 12 blue cubes in the box. Work out the total number of red cubes. So quite a difficult question to do, but so how do you get to a probability? You do the um, number of items out of the total, don't you? That's how you get to the probability. So we know the probability of blue is 0.2. We know there's 12 blue, but in fact, no, we don't even need to do this, do we? Um, no, forget that. Right, we don't need to do this. It's another way to do this. There are 12 blue cubes in the box. Now, the probability of picking a red cube, as you can see, is twice as much, right? There's twice as big there, which means there must be twice as many red things, cubes, as blue ones. So there must be 24 red ones. The red ones and the yellow ones are the same, so that must be 24 as well. So now we know that there's 60 altogether. 12 add 24 add 24 is 60. Jeez. Dan Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar. So if sugar is 50 grams, 3 times as much flour is 150 grams. 2 times as much butter is 100 grams. They're going to make 60 biscuits. Work out the amount of flour she needs. Okay, well, the thing you have to do with these questions, I think we saw a question like this last week. I feel like we did. But if you were here, um, what you need to do, this will be the last question I do, by the way, just for time reasons. If there were 15, um, sorry, what you're looking for is something connecting the number of biscuits for which you have a recipe for and the number you're actually making. And that is, you're making 4 times as many as this recipe says. So that means you need 4 times as many as 4 times as much ingredients. Work out the amount of flour you need. Flour needs to be times by 4, 150 times 4. Just remember, if you're timesing anything by 4, a quick way to do it is to double and double again. So 150 doubles to 300, double it again, 600. That is the answer. And I'm not going to do the remaining questions from this just for there's so many of them. If you have any questions, then there's a WhatsApp to send to. And yeah, that's it. That's all I'm going to do for today. So I'll go at that point.